Here is an effort to explain the significance of negative ratios obtained during the application of section formula. If we have a line segment, we can find out a point Q on it such that it divides the line segment AB in the ratio 2:3. That means QA over QB is 2:3. If we extend this line segment just like a line, then there do exist a point P on the line segment, on the line, which divides this line segment AB externally in the ratio 2:3. That means PA ratio PB is 2:3. That means PA over PB is 2:3. Okay, so a point dividing AB in the ratio 2:3 are two. One is lying on the line segment and one is outside the line segment. So Q is said to divide AB internally and P is said to divide AB externally. To find out the coordinates of Q, we have a section formula, this, and to find out the coordinates of P, we use the section formula, this. This is called internal division and this is called external division. Suppose we have these 3 points and we have to find out the ratio in which this point divides the line segment joining these 2 points. See, these 3 points are collinear. As you have been asked to find out the ratio, that means they are collinear. But there are 2 possibilities. Either this point lie on this line segment or this point lies on the line when this line segment is extended in the both directions. Okay, so if it lies on the line segment, then we should use internal formula, and if it lies outside, then we should external formula. Okay, here clearly this point lies outside because -3 is less than 1 and 3 both. So it's outside and we should use the external formula and we'll get the ratio as 2:3 in this case. Okay, specifically 2:3. But suppose we don't want to get into this this thing of finding out whether this point lies on the line segment or it lies outside the line segment. We just want to apply the section formula. So how will the situation appear? So in that case, here is a Cartesian plane, and how are we visualizing this situation? We are visualizing these 2 points only. No, that these are 2 random points on the Cartesian plane. Okay, and to find out the ratio, what do we do actually? No, we actually find out the x coordinate first. No, so the shadow of these 2 points on the x-axis is this. And how are we visualizing this point? We are visualizing it on this line segment. So let's suppose this is point P and this lies on this line segment. Okay, and now to find out the ratio, we are letting the ratio as k:1. Suppose this point P divides this line segment in the ratio k:1. Okay, so how do we find out the coordinate of this point? No, we have learned through the derivation of section formula that the coordinates of this point is actually k over k plus 1 of this line segment plus 1. If we have to find out the coordinates of this point, we have to travel this much and this much. So this much is 1 and this much is actually k over k plus 1th part of this full line segment, and this full line segment is 2 units. No, 3 minus 1, 2 units. So here the x coordinate of this point is this 1 plus k over k plus 1th of 2. But we have been given this point is this. So the x coordinate here, okay, is actually equals to -3. Now see, we are adding something to 1 and we are getting -3. what does this mean? If we are adding something to 1, it should increase, but it is decreasing. So to reach this value, 2 is positive, 1 is positive. To balance this, k must have a negative value. And it has the negative value, which is this. Okay. So by k is taking the value minus 2 over 3, thereby telling us that to reach this point, we have to go in the opposite direction. From 1, we have to take some steps back. And those, no? So, what is the significance of negative ratio? Whenever we get a ratio as negative, that means the point does not lie on the line segment, it lies outside the line segment. Similarly, if we will calculate the value of k through y-axis, means from the shadow points of these 2 points on the y-axis, we will again get the value of k as minus 2 over 3. Means if we use the formula of internal division. Okay, thereby telling us that the point does not lie on the line segment, it's actually lie externally. And yes, the point was actually here, it wasn't on the line segment. No. So here we can conclude that negative ratio means point is dividing externally. Okay, I hope you understood. Thank you.